Hello and welcome to Science Visualized. Today we're going to look at how to determine whether a structure is aromatic. Actually, we're looking at whether it's aromatic, anti-aromatic, or non-aromatic. And we're going to be using Euclid's 4n plus 2 pi electron rules. If n is 0, 0 times 4 is 0 plus 2 gives you 2. If n is 1, 1 times 4 gives you 4 plus 2 gives you 6. So if you have 2, 6, 10, or 14 electrons, it will satisfy the 4n plus 2 pi rule. If you have 0 electrons, 4 electrons, 8, or 12, that will satisfy the 4n pi electrons, which is actually for anti-aromaticity. So we're able to determine whether something is non-aromatic, aromatic, or anti-aromatic. And basically we're using 3 rules. Rule number 1, is a structure cyclic? Number 2, do you have a continuous conjugation throughout the ring? In other words, you have continuous overlap of p orbitals. So we just say, is it fully conjugated? And then the last one, does it satisfy the Euclid's 4n plus 2 pi rule? Looking at this first structure, number 1, we see that it is cyclic, so that's yes. Number 2, you have this carbon is sp2, so they all have p orbitals, but this one here is sp3, so that fails, so it's not conjugated, fully conjugated, and because of that, this structure is non-aromatic. Number 2, this structure is cyclic. We see that each corner or each atom in the ring has p orbital, so it's fully conjugated, because here you have a double bond, same thing here, same thing there, so it's fully conjugated, satisfies the second rule. And then the next thing is how many electrons are in the ring. We see that each double bond is 2 electrons. The other double bond is 2 electrons, but that one is outside the ring, so we don't count that. So it's only these 2 electrons that are inside the ring, and because of that we say it has 2 electrons, and remember from the rule, 2 electrons satisfies the 4n plus 2 pi electrons, and therefore this structure is aromatic. Next structure, we see that it is cyclic, yes. It's fully conjugated, yes. The number of electrons inside the ring is, each double bond is 2, 2, 2, so total 6 electrons, and as you can see, 6 satisfies that rule. So that also is aromatic. Next one, number 4, cyclic, yes. Fully conjugated, yes. The number of electrons inside the ring, we have 2 and 2, but this oxygen, look at the oxygen, it has 2 pairs of electrons. Each pair will be on a different p orbital. If you remember anything about p orbitals, we have px, py, and pz. They are perpendicular to each other. So that means they don't overlap. That means at any given time, only one p orbitals will overlap with these other p orbitals. And as a result, we can only count one set of electron pairs. So in that case, we have 2 electrons from here. So 2, 2, and 2 gives you a total of 6, which is similar to what we saw before, and therefore that's aromatic. Next structure, it's cyclic, yes. Conjugated, yes, because this carbon has a negative charge, which is basically 2 electrons. The minus charge is on a p orbital, and therefore it's fully conjugated. And then the number of electrons inside the ring, the minus charge counts for 2. Each double bond is 2, so a total of 6 electrons, which satisfies, and therefore it's fully aromatic. Number 6, cyclic, yes. Fully conjugated, yes, because that positive charge is on an empty p orbital. And because of that, you have a complete overlap of p orbitals, and therefore all the electrons are delocalized, but we only have a total of 4 electrons. And because they are 4, that one satisfies the anti-aromatic 4n pi electrons. So that's an anti-aromatic structure. Next, this structure, number 7, is cyclic, yes. Fully conjugated, yes. The number of electrons inside the ring, the double bond here is outside, we don't count that. But here we have 2, 2, and then nitrogen has 1 electron pair, so that counts for 2, and therefore we get a total of 6, and therefore that satisfies the rule, and therefore it's fully aromatic. Structure number 8. Here we have a system that's cyclic, yes. If it's fully conjugated, yes. The reason is because this nitrogen has electron pair which is on a p orbital, and therefore you have an overlap of p orbitals. And then lastly, 4n plus 2 pi electrons, you have a total of 2 electrons on nitrogen. You have 2 electrons on the double bond. Oxygen has a set of 2 electron pairs, but you can only count one of them for reasons that I explained earlier, because they are on different p orbitals, and therefore you have a total of 6 pi electrons, and as a result, that structure is aromatic. Thank you very much. Please remember to subscribe.